The purpose of this recording is to show how to determine the theoretical composition of a compound. For example, I could determine the composition of water. By achieving and determining the composition, I can determine the percent hydrogen as well as the percent oxygen present in water. To do this, I'm going to use the molar masses found on the periodic table for both hydrogen and oxygen. First, I want to show how many hydrogens I have. In this case, I have 2 hydrogens, and I want to show how many oxygens I have. I have 1 oxygen. Taking these values and multiplying by their molar masses found on the periodic table, hydrogen being 1.01 and oxygen being 16.00, I could get the molar mass or the total mass for my water. And so for oxygen, I get 16.00, and for the hydrogen, I'm going to get 2.02. The next step is to add these two values up. By doing that, I determine the molar mass for the water, or the total mass that I'll be dealing with. So I get 18.02, and this is the molar mass of water in atomic mass units. And so if I have the total mass of 18.02, I could then take the mass of hydrogen present and the mass of oxygen present and divide each of those by the total mass, and by dividing by the total mass, I can get the percent composition. And so for the hydrogen, if I take 2.02 and I divide it by 18.02, that will give me the composition for, or the percent composition for hydrogen. And then if I take the 16.00 and divide it by the total 18.02, that will give me the percent composition for the oxygen. And so to do this, I'm just going to take my 2.02 divided by 18.02, and that gives me my percentage. So that's 0.112 as a percentage. That's 11.2%. And so that's 11.2% hydrogen in water. And for oxygen, I'm going to take 16 divided by 18.02, and I'm going to get 88.8% is my portion of oxygen. Once I have the percent composition, I could then use that percent composition and determine a percent error that I might have if I were making water in lab, for instance, or if I were determining the theoretical composition of water in lab. And so if I had the experimental values, so if I worked in lab and I found the experimental values of, let's say, 15% hydrogen and 85% oxygen, just making these up off the top of my head. If those were the experimental values that I found in lab, I could then determine my percent error. To calculate percent error, it's going to be percent error is equal to the absolute value of the error, and that's going to be divided by the theoretical value. And so that's the formula that I would be using to do that. And so the error is the difference between what it should be and what I got. And so my error would be 15 minus what it should be, which is 11.2, and that's going to be all divided by my theoretical value of 11.2. And so 15 minus 11.2 is 3.8 divided by what I should have gotten, the 11.2, and that's going to give me my percent error. So that's 33.9% error, which is actually not very good. But that's how you would calculate the percent error. So that's it. I hope this video was helpful.